It's ancient Alexandria, buzzing with scholars hunched over scrolls filled with strange symbols. Here, a Greek mathematician debates the nature of infinity, while the faint scratch of a stylus etches numbers that will echo through millennia. What secret alchemy turns these marks into powerful truths? This journey through the history of mathematics, through lives and breakthroughs, reveals how we went from counting sheep to bending the very fabric of reality with numbers. Mathematics didn't begin with some lofty idea. It started with survival, counting, measuring, trading grounded in daily life's gritty details. But how did those first tallies grow into a vast language of symbols and concepts? Back in 3000 BCE Egypt, math was everything from managing grain stores to designing pyramids. Rouse Ball walks us through ancient papyri that record calculations as detailed as measuring fields and dividing land, all precise, all necessary. These early pragmatists unknowingly planted seeds for geometry and algebra by solving real-world problems with numbers and shapes. Think of early numbers as the alphabet's first letters. At first, numbers were just marks like tally sticks or knots, but gradually they formed a system. Like learning to read before writing poetry, ancient mathematicians developed symbolic notation to manipulate these letters, enabling calculations that transcended simple counting, unlocking abstract thinking. These primitive steps weren't isolated tricks. They built a sturdy stage where future giants, Greek geometers, Arab algebraists would perform their masterpieces. The practical became philosophical. The transition from concrete to abstract is the secret gear that still powers modern math, linking everyday needs to infinite possibilities. Jump to Athens around 300 BCE. Here, math transforms into an art of logical proof and deep puzzles. Yet these thinkers faced brutal challenges, unsolvable problems that would haunt mathematicians for centuries. Euclid walks into the spotlight with his legendary Elements, a 13-book masterpiece that organizes all known geometry into tightly wrapped theorems and proofs. Rouse Ball highlights how this was no dusty textbook. It became the gold standard for clarity and rigor, influencing not only mathematics but philosophy and science for thousands of years. But the Greeks didn't just build tidy theories. They wrestled with impossible puzzles like squaring the circle, trying to craft a square equal in area to a given circle using just a compass and straight edge. It was like chasing a shadow, a headache that would resist solution until centuries later, teaching us humility and patience in math's journey. What changed everything was their obsession with proof. Math became less about finding answers and more about knowing answers beyond doubt. This shift from practical rule of thumb to rigorous reasoning was the true revolution, transforming math into an unshakable tower built brick by logical brick. Fast forward to the Islamic Golden Age and beyond, where numbers leap into new forms and the dawn of calculus redraws math's horizons. But how did these contributions connect the dots between old puzzles and new frontiers? Muhammad ibn Musa al-Khwarizmi in 9th century Baghdad doesn't just write a math book, he invents algebra as we know it. Rouse Ball paints a vivid picture of his work translating geometric problems into equations, unleashing a tool that would revolutionize problem-solving across cultures. The word algorithm even comes from his name. Symbolism turned math into a language of abstraction, letters for unknowns, signs for operations. Like inventing shorthand for thought, this leap allowed mathematicians to manipulate ideas far beyond what words could express, making calculations faster and concepts clearer, a cognitive superpower that fuels every advance since. Then comes calculus, the breathtaking invention of Newton and Leibniz in the 17th century. This math of change finally decoded motion from falling apples to planetary orbits. Riemann and others later hardened its foundations, allowing math to model the physical world with jaw-dropping precision, a tool so powerful it underpins modern physics and technology. Back in Alexandria, that debate on infinity wasn't just idle chatter. It was the spark of a long quest we're still part of today. The story of mathematics is a living one, practical hands shaping abstract ideas, persistent minds solving eternal riddles. Next time you see numbers, remember they're the traces of countless thinkers, and your own curiosity can continue their journey. Try this, spot one everyday problem and ask, how would the ancients have counted this? Subscribe for more book summaries like this one.